morning to one and all. I am Venkatesham. I am going to discuss about Vant factor derivation and Vant factor calculation. Find experimental molar mass. Okay. So in association case here some problems are there. In that first one, if acetic acid is dissolved in benzene, then it converted as a dimer. Find its experimental molar mass. So acetic acid like a CH3COOH is a acetic acid formula, and it is converted when it is dissolved in a benzene, and it converted as a dimer. Dimer means CH3COO, and here it is a H taken twice. So this is 2, and here when it is completely converted as a dimer, and its Vant factor I is equals to, I can write down as a 1 by n, and here n value is equals to there is a 2, so that its a Vant factor I is equals to 1 by 2, that is nothing but 0.5. Okay, so here they are asking its experimental molar mass, and Vant factor I is equals to m normal divided by this is an m experimental. Okay, so Vant factor I want experimental molar mass here. They are asking to find experimental molar mass, so that here m experimental is equals to, that is in m normal is acetic acid generally 60 is there, divided by Vant factor 0.5, and after simplification this is in 120 is the experimental molar mass. Okay, so this is one problem. Here second problem. The second problem is the boiling point of pure benzene is given as this is simply TB naught is given as 80 degrees centigrade, and 0.2 moles of solute dissolved in and 2 kg of benzene. That means here number of moles n is given as 0.2, and 60% alpha is nothing but 60%. Now 60% means 60 divided by 100. I can write this is simply 0.6 is a degree of association. Here Vant factor I is equals to, this is 1 minus alpha into n minus 1 divided by, here it is a n. Delta TB is equals to, we can write down the I into KB into m. Okay, so that I value you can substitute in that one. I is equals to, I can write here 1 minus alpha is 0.6 here n. Trimer means n, we will write down this is 3 minus 1 divided by, here it is 3. So that means here after simplification this, so 0.6 is I value. Here T delta TB I can write down, this is in a TB minus this is a TB naught, that is equals to 0.6 into here 2.5 into molality. I can write down the number of moles of solute divided by its how many kgs they have given, 2 kgs. That means here it is 0.2 divided by 2 kgs, this is 0.1 only will get, and after simplification this one is 0.15 will get, and TB naught, TB minus 80 they have given, and here it is a TB is equals to 80.15 degrees centigrade. Okay, so this is just next. Third problem is the non-volatile solute dissolved in water, then it is associated as a trimer, and Vant factor I is equals to 0.4. Find degree of association. Here trimer means n is equals to, they have given as a 3, and Vant factor I is given as that is in a 0.4 in this problem. They are asking to find its a degree of association alpha. Alpha is equals to, we have a formula, that is in a 1 minus I into n divided by, this is in a n minus 1 is a formula for finding the, this is a degree of association. And the degree of association formula alpha is equals to 1 minus I into n divided by n minus 1. Here 1 minus I is 0.4, and the n value is a 3 divided by here it is a 2, and simply we'll get this is a 0.6 0.6 into 3 divided by here it is 2, this is a 0.3, and you will get this is a 0.9 percentage, or I can write this is a 0.9 percentage of alpha is equals to, that is in a 90%. So this is a simply a degree of association.